Good evening, my dear students. Today we are going to discuss our last chapter, carbon and its compound. Carbon and its compounds. First, we are going to discuss bonding in carbon. Bonding in carbon. That is the covalent bond of carbon. We know that carbon is a versatile element that forms the basis for all living organisms. Carbon compounds have very low melting point and a boiling point. Carbon compounds have very low boiling point and melting point. And carbon compounds are poor conductor of electricity. Carbon compounds are poor conductor of electricity. Some common properties of carbon compounds have low melting point and low boiling point. Carbon compounds are poor conductor of electricity. Then we know that next we are going to discuss electronic configuration and valency. Electronic configuration and valency. We know that atomic number of carbon is 6. Atomic number of carbon is 6 and mass number of carbon is 12. And electronic configuration of carbon. Electronic configuration of carbon is 2, 4. 2 electrons in the K shell and 4 electrons in the L shell. Electronic configuration of carbon is 2, 4. 2 electron in the K shell and 4 electron in the L shell. Number of valence electron present in the carbon atom. Yes, it's 4. Number of valence electron present in the carbon atom is 4. The valence shell is L shell. Valence shell is L shell, or second energy level is the valence shell in the case of carbon atom. Number of valence electron present in the carbon atom is only 4. 4 valence electron present in the carbon atom. And valency. What is the valency of the carbon atom? In the case of sodium, atomic number 11, electronic configuration 281. Valence electron is 1 and the valency of sodium is 1. In the case of magnesium, atomic number 12, electronic configuration 282. Number of valence electron is 2 and the valency of magnesium is 2. In the case of oxygen, atomic number of oxygen is 8. Electronic configuration is 2, 6. Number of valence electron present in the oxygen atom is 6. And the valency of oxygen atom, valency of oxygen atom is not 6, it's 2. Valency of oxygen atom is 2. Valency of oxygen atom is 2. That means oxygen require 2 more electron to complete their octet. Oxygen require 2 more electron to complete their octet. So valency of oxygen is 2. But valency of sodium and magnesium, that is equal to number of valence electron. In the case of oxygen, valency is 2. That means oxygen require 2 more electron to complete their octet. Valency of chlorine, electronic configuration is 287. Atomic number is 17. Electronic configuration of chlorine is 287. Chlorine required 1 more electron to complete their octet. 1 more electron. Chlorine require 1 more electron to complete their octet. So the valence of chlorine is 1 and the valence electron present in the chlorine atom is 7. Here we are discussing carbon atom. Electronic configuration of carbon is 2, 4. Valence electron is 4 and the valency of carbon atom. Valency of carbon atom means how many electrons required to complete their octet. Carbon atom required 4 more electron. Carbon atom required 4 more electron to complete the octet. So valency of carbon atom, that is equal to valence electron. Valency of carbon atom is equal to valence electron, that is equal to 4. Valency and number of valence electron of carbon atom is 4. Electronic configuration is 2, 4. 2 electrons in the K shell and 4 electrons in the L shell. L shell is the outermost shell or valence shell. Okay, is it clear? And valency, note down, valency of carbon atom is 4. Valency of carbon atom is 4. Note down this one. Valency of carbon atom. Valency of carbon atom is 4. Valency means number of electrons required to complete the octet. Carbon required 4 more electron to complete their octet. So valency of carbon is 4. And for next one, formation of covalent bonds. Formation of covalent bond. Covalent bonds formed by sharing of electron pairs. Sharing of electron pairs between atoms. We know that ionic bonds. Ionic bonds formed by a metal release an electron to form corresponding cation, and non-metal accept that electron and to form corresponding anion. The cation and anion interaction, or positively charged or negatively charged particle interaction, and to forming an ionic bond. But here covalent bond is formed by sharing of an electron pair. Sharing of an electron pair between the atoms. Sharing of an electron pair. Carbon forms covalent bonds with many elements like hydrogen, oxygen, nitrogen, sulfur, chlorine, etc. In a covalent bond, both atoms attain noble gas configuration. For example, hydrogen molecule, chlorine molecule, oxygen molecule, nitrogen molecule, and methane molecule. Methane. Molecular formula of methane is CH4. Okay. Then covalent bond formation of hydrogen molecule, H2 molecule, H2. Two hydrogen atoms combine to form H2 molecule. Two hydrogen atoms combine to form H2 molecule. We know that atomic number of hydrogen is 1. That means it has only one electron. And the configuration of hydrogen is 1. It has only one shell, that is K shell. K shell has only one electron. Valence shell is also K shell. It has only one electron. Number of valence electron present in hydrogen atom, that is also 1, because only one shell is present. So the number of valence electron is only 1. And here two hydrogen atom combined. And these two hydrogen atoms share this pair of electron and to form hydrogen molecule. This electron for first hydrogen atom and this electron for second hydrogen atom. And these two hydrogen atoms share a pair of electron and to form H2 molecule. Share a pair of electron. Here two hydrogen atoms share a pair of electron. That means 2 electron. Two hydrogen atoms share 2 electron and to form hydrogen molecule. Here two hydrogen atoms share a pair of electron. So bond between two hydrogen atoms is a single bond. Bond between two hydrogen atoms is 1. One bond is present, the bond is called single bond. More than one bond is present, the bond is called multiple bonds. In the case of H2 molecule, single bond is present because here only one pair of electron is shared. One pair of electron is shared, or 2 electron. One pair means 2 electron. Then next example is chlorine molecule. Formation of chlorine molecule. Two chlorine atom combine to form Cl2 molecule. Two chlorine atom combine to form Cl2 molecule. Two chlorine atom combine to form Cl2 molecule. Atomic number of chlorine is 17. Electronic configuration is 287. Electronic configuration of chlorine is 287. Electronic configuration of second chlorine, that also 287. And each chlorine atom require one more electron to complete their octet. Here configuration is 287. Valence shell Valence shell contain 7 electrons. That means chlorine atom require 1 more electron to complete their octet. Both chlorine atom require 1 more electron to complete their octet. In the formation of Cl2, these chlorine atoms share a pair of electrons and to form Cl2 molecule. First draw the electron dot structure of chlorine atom. Electron dot structure, valence shell containing 7 electron. So represent the 7 electron. 1, 2, 3, 4, 5, 6, 7. Then the second chlorine atom. Electronic configuration of the second chlorine atom is also 287. That means valence shell containing 7 electron. Both chlorine atom require 1 more electron to complete their octet. That means the two chlorine atoms share 1 pair of electron, or two chlorine atoms share their 2 electrons. 2 electrons and complete their octet to form Cl2 molecule. Here the green chlorine atom share an electron from pink chlorine atom, and pink chlorine atom share an electron from green chlorine atom and complete their octet. Count the number of electrons. Here in the green chlorine atom, now the green chlorine atom has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And count the number of electron present in the pink chlorine atom. 1, 2, 3, 4, 5, 6, 7 and 8. Now both the chlorine atom has 8 electrons. That means this molecule is stable. Cl, it share a pair of electron. Cl, single bond Cl. Single bond means it share a pair of electron. If two atoms share a pair of electron to form a single bond, two atoms share a pair of electron, or two atoms share 2 electrons to form a single bonded compound. Cl, single bond Cl. Here both chlorine atoms share a pair of electron to form Cl2 molecule. This is Cl2 molecule. Here 1, 2, 3, 4, 5, 6, 7. Here 1, 2, 3, 4, 5, 6, 7. Okay, is it clear? Next example is oxygen molecule, O2 molecule. O2. Formation of O2 molecule. Atomic number of oxygen is 8 and electronic configuration is 2, 6. Each oxygen atom has 6 valence electron and each oxygen atom require 2 more electrons to complete their octet. Each oxygen atom require 2 more electrons to complete their octet. So these two oxygen atoms share 2 pair of electrons. These two oxygen atoms share 2 pair of electrons. 2 pair of electrons means 4 electrons. First oxygen, it has 6 valence electron, and green one is the second oxygen. Green one is the second oxygen. It has also 6 electron, 6 valence electron. Both the oxygen require 2 more electron. Both the oxygen require 2 more electron to complete the octet. So both the oxygen share 2 pair of electron. this oxygen, pink color oxygen share these 2 electrons, and the green color oxygen share these 2 electron also. Here both the oxygen atoms share 2 pair of electrons. That means total 4 electrons. Both the oxygen atoms share 2 pair of electrons for complete the octet and to form multiple bond. Here 2 bonds are formed. That means oxygen bond is a multiple bond. The number of multiple bond is 2. The bond is called a double bond. Oxygen bond is a double bond. Double bond. Chlorine bond. Chlorine bond is a single bond. The bond between 2 chlorine atoms is only one. That is a single bonded compound. The bond between 2 oxygen atoms is 2. That means it's a double bonded compound. Oxygen molecule is a double bonded compound. Bond between 2 oxygen atoms is 2. Oxygen double bond is present because each oxygen atom requires 2 more electrons to complete their octet. Okay, is it clear? The next example is nitrogen molecule. Next example, nitrogen molecule. Nitrogen is N2. We know that atomic number of nitrogen is 7. 2 nitrogen atoms combine to form nitrogen molecule. Atomic number of nitrogen atom is 7. Electronic configuration is 2,5. Electronic configuration is 2,5. 2,5 means it required 3 more electrons. 3 more electrons to complete their octet. Each nitrogen atom requires 3 more electrons. 5 plus 3, that is 8. So 3 more electrons to complete their octet. That means each nitrogen atom shared 3 pair of electron. Each nitrogen atom shared 3 pair of electron or 6 electron to form nitrogen molecule. Draw the electron dot structure. Valence shell containing 5 electron. 1, 2, 3, 4, 5. This is the electron dot structure of nitrogen atom. And the second nitrogen atom, 1, 2, 3, 4, 5. Here each nitrogen atom requires 3 more electron. So each nitrogen atom share 3 electrons. This nitrogen atom, the green color nitrogen atom shared 3 electrons from the pink color nitrogen atom, and the pink color nitrogen atom also shared the 3 electrons from the green color nitrogen atom for complete the octet to form N2 molecule. Here the bond between 2 nitrogen atom is 3. That means it share 3 pair of electron. The bond between 2 nitrogen atom is 3. That means it share 3 pair of electrons. Or 6 electrons. So N2 molecules. The bond between N2 molecule is a triple bond. N2 molecule is a triple bond. N triple bond N. N2 molecule. Bond between 2 nitrogen atom or bond between nitrogen molecule is triple bond because it shared 3 pair of electron or it shared 6 electron. If 2 atoms shared 1 pair of electron or 2 electron, that means it formed single bonded compound. It shared 2 pair of electron or 4 electron. 4 electron. That means it will form double bonded compound. And the molecule shared 3 pair of electron. 3 pair of electron or 6 electron. 6 electron. 3 pair of electron, or it will share 6 electron. That means the bond between two elements is triple bond. Single bond and double bond and triple bond are also known as multiple bonds. Double bond and triple bond are also known as multiple bonds. Single bonds means it shared only 1 pair of electron. Double bond means it shared 2 pair of electron. Triple bond means it shared 3 pair of electron. Number of bonds between two atoms is 3. That means it's triple bond. Number of bonds between two atoms, it's 2, is called double bond. Number of bonds between two atoms is 1, is a single bonded compound. Okay. Then last example, methane molecule. Methane. Molecular formula of methane is CH4. 1 carbon and 4 hydrogen combined to form CH4 molecule. 1 carbon atom and 4 hydrogen atom combined to form CH4 molecule. We know that atomic number of carbon is 6, electronic configuration is 2, 4, and atomic number of hydrogen is 1, and the electronic configuration is 1. Then we know that carbon required 4 more electrons to complete their octet. Carbon required 4 more electrons to complete their octet. 4 plus 4, 8. But hydrogen required only 1 electron. Hydrogen required only 1 electron because hydrogen has only one shell. Only one shell, that is K shell. Maximum number of electrons present in K shell is only 2. So hydrogen required only 1 more electron, but carbon required 4 more electrons to complete their octet. Electron dot structure of carbon is this one. Carbon atom has 4 valence electron, and electron dot structure of hydrogen is this one. Hydrogen has only 1 valence electron. Hydrogen required 4 more electrons to complete their octet. That means, carbon required 4 more electrons to complete their octet. But hydrogen require only 1 more electron because hydrogen has only K shell. The maximum number of electrons present in the K shell is only 2. So hydrogen required only 1 more electron. Here carbon required 4 more electron. That means carbon combined with a 4 hydrogen atom. Carbon combined with a 4 hydrogen atom to form methane molecule, CH4 molecule. Carbon has 4 valence electron and it combined with the 4 hydrogen atom and shared the hydrogen electron. We know that each hydrogen atom has 1 electron. Each hydrogen atom has 1 electron. Okay. Each hydrogen atom share 1 electron from carbon atom to complete the valence electron to fill the K shell. And carbon atom shared 4 hydrogen atom. Carbon atom shared 4 hydrogen atom and complete the octet. Count the total number of carbon atoms, count the total number of electrons present around the carbon atom. 4 electrons from the carbon atom and 4 electrons from the hydrogen atom. Total 8 electrons present around the carbon atom. It satisfied their octet. So the formula of CH4 is C. Here in this bond, here it share only 1 pair of electron. That means this carbon hydrogen bond is a single bond because share only 1 pair of electron. 1 electron from carbon and 1 electron from hydrogen. In here also it share only one pair of electron. That means this bond is also a single bond. And this one, note it, here also it share a pair of electron or two electron. That means that bond is also single bond. And here also it share a pair of electron. That means a single bond. So the structure of CH4 is C single bond H, single bond H, single bond H, single bond H. Carbon atom, the number of bonds between each carbon and hydrogen is only 1. So the 4 bonds are single bond. 4 bonds are single bonds. CH4, CH single bond, CH single bond, CH single bond, CH single bond. Both the bonds are single bond. Okay, this is the structure of methane molecule. Okay, is it clear? Do this problem. What would be the electron dot structure of carbon dioxide which has the formula CO2? CO2. Carbon and oxygen. Carbon and oxygen combine to form CO2. Atomic number of carbon is 6. Electronic configuration 2, 4 and atomic number of oxygen is 8. Electronic configuration 2, 6. Carbon atom require 4 more electron to complete their octet, and oxygen atom required 2 more electron. Oxygen atom required 2 more electron. We can draw that structure. Carbon and 2 oxygen combined. Carbon and 2 oxygen, because the formula of carbon dioxide is CO2. Each carbon atom required 4 more electron, but each oxygen atom required only 2 electrons. Oxygen required only 2 electrons, but carbon required 4 more electrons. Carbon dioxide, 1 carbon atom and 2 oxygen atoms are present. And the valence shell of carbon. Valence electron present in the carbon is 4. 1, 2, 3, 4. The cross symbol represents the carbon's electron. And number of valence electron present in the oxygen is 6. The dot represent oxygen's electron. 1, 2, 3, 4, 5, 6. And here also oxygen atom is present. That means it has 6 valence electron. This oxygen atom first oxygen atom require 2 more electron to complete the octet. 2 more electron. That means this oxygen atom share 2 electron from the carbon and complete their octet. Okay. And this oxygen atom also require 2 more electron to complete their octet. So this oxygen atom also share 2 electron from carbon atom and complete their octet. And carbon atom required 4 more electron. So this carbon atom shared 2 electron from first oxygen atom and 2 electron from second oxygen atom and complete their octet. The bond between carbon atoms, COO. Here in first CO bond, here total 4 electrons are shared. 4 electrons. That means 2 pair of electrons are shared. Share 2 pair of electrons. The bond between first oxygen and carbon atom is double bond. And carbon and second oxygen atom. Here also 4 electrons are shared. 4 electrons means 2 pair of electrons are shared. C double bond O. The structure of carbon dioxide is C double bond O, double bond O. Okay, this is the structure of carbon dioxide. Total number of double bonds 2. Is it clear? This is the electron dot structure of carbon dioxide molecule. Electron dot structure of carbon dioxide molecule. Which type of multiple bond present in the carbon dioxide molecule? Which type? Double bond. Double bond is present in carbon dioxide. Okay. Let's summarize this topic. Covalent bond is formed by the sharing of electron pairs between atoms. Carbon forms covalent bond with many elements like hydrogen, oxygen, nitrogen, sulfur, chlorine, etc. In a covalent bond, both atoms attain noble gas configuration. For example, hydrogen molecule H2, H single bond H, single bond. Here single bond is present. Cl single bond Cl, Cl2 molecules here also single bond. And oxygen molecule, we know that formation of oxygen or double bond or double bond, it share two pair of electron or it share 4 electron. Two oxygen atoms share 4 electron or two pair of electron. That means bond between two oxygen atom is double bond. Nitrogen molecule, it's triple bond. And methane, carbon atom with a 4 hydrogen atom. Carbon atom with 4 hydrogen atom. CH4, C single bond H, single bond H, single bond H, single bond H. CH4 molecule. Both are single bond. Both hydrogen atoms share a pair of electron. Okay. Then next point, properties of covalent compound. Properties of covalent compound. It exits as gases, liquids or low melting point solid. Covalent compounds. Covalent compounds exist as gases, liquids or low melting point solids. Gases, liquids or low melting point solids. Okay, next, it's a poor conductor of electricity. Poor conductor of electricity. No charged particles or ions. Poor conductor of electricity because they have no charged particles or ions. But ionic compounds are good conductor of electricity because they have ions, positively or negatively charged ions. So they are good conductor of electricity. But in the case of covalent compound, they are poor conductor of electricity because they have no charged particles. No charged particle. That means it has no ions, cation or anions. So they are poor conductor of electricity. Then they generally insoluble in water. Covalent compounds generally insoluble in water and soluble in organic solvent. Insoluble in water and soluble in organic solvent. Generally insoluble in water and soluble in organic solvent. But in the case of ionic compound is generally soluble in water. Soluble in water. In the case of covalent compounds, generally insoluble in water and soluble in organic compound. Organic compound like benzene, heptane, etc. They have strong bonds within the molecule. Strong bonds within the molecule but weak intermolecular force. Weak intermolecular force. Okay, these are the some properties of covalent compounds. Okay. Next topic is versatile nature of carbon. Versatile nature of carbon. First nature is catenation. Catenation means carbon atom can form bond between other carbon atoms. Carbon-carbon bonds. Carbon atoms can form bond between another carbon atoms. That property is known as catenation. But other elements like sodium, lithium, potassium, phosphorus, they have low ability to form the bonds like this. Catenation means carbon has unique ability to form bonds with other carbon atom. Carbon-carbon bonds. Carbon-carbon bonds are formed. That property is known as catenation. Catenation, carbon-carbon bonds. Catenation, formation of long chain, branched chain or rings of carbon atom. Formation of long chain, branched chain or rings of carbon atom. The stability of carbon-carbon bonds allows for the formation of a large variety of compounds. No other elements exhibit catenation to the extent that carbon does. Okay, no other elements exhibit catenation to the extent that carbon does. Catenation means formation of carbon-carbon bonds. Same elements combined to form different types of compound, that is catenation. Formation of carbon-carbon bond. Carbon has unique ability to form bonds with other carbon atom. Bonds with other carbon atom. That property is known as catenation property. That property is known as catenation property. Okay. Then next property is tetravalency. Tetravalency. We know that the configuration, electronic configuration of carbon is 2, 4. Total number of electrons present in the carbon atom is 6. So the electronic configuration of carbon is 2, 4. The valence electron present in the carbon atom is 4 and carbons require 4 more electrons to complete their octet. 4 plus 4 8. Carbon require 4 more electrons to complete their octet. That means valency of carbon is 4. Carbon has a valency of 4. Then it can form bonds with up to 4 other atoms of carbon or other elements. It can form bond with up to 4 other atoms of carbon or other elements, and ability to form strong bonds with many elements like hydrogen, oxygen, nitrogen, sulfur, halogens, etc. Okay, CH4, methane molecule. Here carbon forms bonds with the 4 hydrogen atom. Carbon forms bonds with the 4 hydrogen atom, CH4. This is methane molecule. And chloroform. Chloroform is chemically CHCl3. Here carbon atom form bond with 1 hydrogen atom and 3 chlorine atom. 1 hydrogen atom and 3 chlorine atom. CHCl3, it is chloroform. And CCl4, carbon tetrachloride, CCl4. Here carbon atom forms bond with the 4 chlorine atom. That means carbon has the ability to form strong bonds with many elements. Hydrogen, oxygen, nitrogen, sulfur, halogen. Halogens are fluorine, chlorine, bromine, iodine, and astatine. They are halogens. Fluorine, chlorine, bromine, iodine, and astatine. Next, types of carbon compounds. Types of carbon compound. Saturated and unsaturated carbon compound. Saturated and unsaturated carbon compound. Saturated compounds and unsaturated carbon compound. Saturated carbon means, saturated compounds mean carbon atoms linked by single bonds only. Carbon atoms linked by single bonds only. Carbon-carbon single bonds. Only carbon-carbon single bonds are present. That means the compound is saturated compound. Saturated compound means in that compound containing only carbon-carbon single bonds are present. Carbon-carbon single bond. Carbon atom linked by single bonds only. Only carbon-carbon single bonds are present. No multiple bonds are present. That type of molecule is known as saturated molecule or saturated compound. For example, all alkanes are saturated. All alkane molecules are saturated molecule. Ethane is an example for alkane. Ethane. The formula of ethane is C2H6. C2H6. How to draw the structure of ethane? C2. Total number of carbon present in ethane molecule is C2. 2 carbon atoms. We know that Each carbon atom has 4 valence electrons. 1, 2, 3, 4. Here also 1, 2, 3, 4. Each carbon atom has 4 valence electrons, and each carbon atom requires 4 more electrons. 4 more electrons. Here ethane is C2H6. C2, 2 carbon atoms are present. Here 2 carbon atom is connected. 2 carbon atoms shared this pair of electrons. One valence is satisfied. Then another 3 valence is unsatisfied. The remaining 3 valencies of each carbon atom satisfied by hydrogen atom. Total 6 hydrogen atoms are present. 1, 2, 3, 4, 5, 6. The remaining 3 valencies of carbon atoms satisfied by 3 hydrogen atoms. And now count the number of electrons present around each carbon atom. Here 8. Here also 8. And hydrogen shared this pair of electrons. This is the electron dot structure of C2H6, and the structure of C2H6. 2 carbon atom is present. 1 carbon-carbon single bond is present. Then first carbon atom connected to 3 hydrogen atom. 3 hydrogen atom by a single bond. Second carbon atom also connected to 3 hydrogen atom. 3 carbon-hydrogen single bonds are present. Total 1 carbon-carbon single bond and 6 carbon-hydrogen single bonds are present in C2H6 molecule. Okay. This is the structure of ethane molecule. Ethane molecule. Is it clear? Ethane molecule is saturated or unsaturated? Ethane molecule is saturated because carbon-carbon single bond. Because here carbon-carbon single bond is present. Saturated compounds formed by carbon-carbon single bonds. Carbon-carbon single bonds. It is a saturated compound. It is a saturated compound. Next C3H8. C3H8 is propane. Propane. Molecular formula of propane is C3H8. Draw the structure of C3H8, propane. Propane is also an alkane. The name alkane ends with ANE. Alkanes end with the ANE. Ethane. Ethane, it's end with the ANE. That means ethane is an alkane. Is an example for alkane. Propane. Propane. The name ends with the ANE. Propane is an alkane. Okay. The molecular formula of propane is C3H8. Draw the structure of C3H8 or draw the structure of propane. Draw the structure of propane. How to draw? Count the number atom. How many? Count the carbon atom. How many carbon atoms are present? C3. 3 carbon atoms are present. Each carbon atom has 4 valence electrons. Okay. Okay. Then connected each carbon atom. Connected each carbon atom. This pair of electron. First carbon atom shared this electron. And this pair of electron is also shared. Okay. Then valency of this carbon atom is not satisfied. In the first carbon atom, 3 valency is not satisfied. 3 valency, these three valency is not satisfied. Here, this valency is satisfied by hydrogen atom. Total 8 hydrogen is present. 8 hydrogen atoms are present. 3 hydrogen atoms combined with the first carbon atom. 3 hydrogen atom combined with the first carbon atom and to complete their octet. Okay. Now the first carbon atom satisfied the octet. Then second carbon atom. Second carbon atom satisfied the 2 valencies only. The 2 valencies are unsatisfied. These the two unsatisfied valencies are satisfied by 2 hydrogen atom. Okay. And the last hydrogen combined with the 3 hydrogen atom. The remaining 3 valencies satisfied by last 3 hydrogen atom. Total 3 hydrogen and 8 hydrogen atoms are present. Then bond. Carbon C3. 3 carbon C single bond C single bond C. 2 carbon bonds are present. Then first carbon combined with the 3 hydrogen. Second carbon combined with the 2 hydrogen. Third carbon combined with the 3 hydrogen. Total 8 hydrogen atoms and 3 carbon atoms. C3H8. Propane. This is the structure of propane molecule. C3H8. Propane molecule. Okay. Is it clear? The next one, unsaturated compounds. Saturated compounds means carbon-carbon single bond. The bond between 2 carbon atoms are single bond. That type of compound is known as saturated compound. Then next, unsaturated compounds. Unsaturated compounds mean carbon atoms linked by double bond or triple bond. Carbon atoms are linked by double bonds or triple bond. That means carbon-carbon double bond or carbon-carbon triple bonds are present. Carbon-carbon double bond or carbon-carbon triple bonds are present in unsaturated compound. Carbon-carbon double bond or carbon-carbon triple bonds are present. Multiple bonds are present. That type of molecule is known as unsaturated compounds. But a compound containing only carbon-carbon single bond is present. Carbon-carbon single bond. Carbon-carbon single bond is present. That molecule is known as saturated molecule or saturated compound. And carbon-carbon double bonds are present. That molecule is double bond or triple bonds are present. That molecule is unsaturated molecule. Example, all alkenes and alkynes. Alkene is double bonded compound. Alkenes are double bonded compounds and alkynes are triple bonded compounds. Alkenes are double bonded compounds and alkynes are triple bonded compounds. The name ends with alkene is ene. Ethene. Ethene is an example for alkene. And alkyne ends with yne. The name alkyne ends with yne. Ethyne. It ends with yne. So ethyne is an alkyne. Unsaturated compounds are more reactive than saturated compounds. Unsaturated compounds are more reactive compared to saturated compound. Then structure of ethene. Ethene is molecular formula of ethene is C2H4. C2H4. 2 carbon atoms. 2 carbon atoms and 4 hydrogen atoms are present. Here, a carbon-carbon double bond is present. Both carbon atoms share 2 pair of electrons. and remaining two valence is satisfied by hydrogen atom. Remaining two valence is satisfied by hydrogen atom. Here also remaining two valence is satisfied by hydrogen atom. This is the structure of C2H4. Carbon, carbon double bond and carbon, hydrogen, single bond. The bond between two carbon atom is double bond. That means this compound is unsaturated. And another one, ethyne molecule. Molecular formula of ethyne is C2H2. Carbon, carbon. And two hydrogen atoms are present. Two hydrogen. One hydrogen for first carbon and second hydrogen for second carbon. And remaining three valencies of carbon is unsatisfied. That means this carbon share three pair of electron. Three pair of electron to form triple bond. Like this. C triple bond C and C single bond H, single bond H. Here also carbon carbon triple bond is present. Carbon carbon triple bond. That means it's an unsaturated compound. Unsaturated compound. Carbon carbon triple bond is present. That means the molecule is an unsaturated molecule. Unsaturated molecule. Suppose CH3, CO, CH3. This molecule is saturated or unsaturated? This molecule is saturated or unsaturated? Check the carbon-carbon bonds. All carbon-carbon bonds are single bond. That means this compound is saturated compound. This compound is saturated. Here one multiple bond is present, but the multiple bond is carbon-oxygen multiple bond. The multiple bond between carbon and oxygen atom. Saturation and unsaturated. Saturated compound and unsaturated compound. It containing carbon-carbon bond. It count the carbon-carbon bonds. Carbon-carbon single bond is present. The molecule is saturated. Carbon-carbon multiple bonds, double bond or triple bond is present. The molecule is unsaturated. This compound is saturated compounds because all carbon atoms connected by single bond. Carbon-carbon single bonds are present. Here carbon-oxygen double bond is present, but saturated compound means carbon-carbon double bond, carbon-carbon single bonds. Carbon atom connected to single bonded carbon atoms. Carbon-carbon bonds, here not only carbon-carbon bonds. Okay. Next, chains, branches and rings. Chains, branches and rings. Chain, branches and rings. For example, methane molecule. Methane is CH4. Molecular formula of methane is CH4. Carbon connected to 4 hydrogen atoms. This is the structure of methane molecule. Methane molecule. And next, ethane molecule. Ethane Ethane. Ethane. Molecular formula of ethane is C2H6. Molecular formula of ethane is C2H6. And the structure of ethane. Structure of ethane. Here, two carbon atoms are present, carbon-carbon single bond, and each carbon atom connected to 3 hydrogen atoms. This is the structure of ethane. This is the structure of ethane molecule. This is the structure of ethane molecule, C2H6. Then next one, propane. Propane. Molecular formula of propane is C3H8. C3H8. Molecular formula of propane is C3H8. Total 3 carbon atom and first carbon atom connected to 3 hydrogen atom. Now the valency is satisfied. Second carbon atom. Here also 2 valencies are satisfied. Remaining 2 valencies satisfied by 2 hydrogen atom. Here only 1 valency is satisfied and the remaining 3 valencies satisfied by 3 hydrogen atom. This is the structure of propane molecule. And next one, butane. Butane. Molecular formula is C4H10. C4H10. 4 carbon atoms are present. Then first carbon atoms only satisfied 1 valencies. Then the remaining 3 valencies satisfied by 3 hydrogen atoms. The second carbon atom satisfied 2 valencies. The remaining 2 valencies satisfied by 2 hydrogen atoms. Third carbon atom also satisfied 2 valencies. 2 valencies. The remaining 2 valencies satisfied by 2 hydrogen atom. And the last carbon atom satisfied only 1 valency and the remaining 3 valencies satisfied by 3 hydrogen atom. This is the structure of butane molecule. This is the structure of butane molecule. These are long chain molecule. These are long chain molecule because all carbon atom connected like a chain. That type of molecule is called a chain molecule. Chain molecule. Carbon atoms are connected like a chain. This ethane, propane, butane, etc. are example of chain molecule. Chain molecule. Okay, is it clear? Next one, branched molecule. Branched molecule means, suppose propane. Propane is, suppose butane. Butane is C4H10. C4H10. 4 carbon atom and first carbon atom connected to 3 hydrogen, second carbon atom connected to 3 hydrogen and fourth carbon atom connected to first carbon atom and fourth carbon atom connected to 3 hydrogen, second and third carbon atom connected to 2 hydrogen atoms. This is the structure of propane molecule. We can draw like this. The 4 carbon atom connect like this. In this type, the 4 carbon atom connected like a chain. This one is a chain molecule. This structure is chain. 4 carbon atom connected like a chain. And suppose if the 4 carbon atom connected like this, 1 carbon and the middle carbon connected to 3 other carbon. And the structure, first carbon, here only 1 valency is satisfied, the remaining 3 valency is satisfied by 3 hydrogen atom. In this carbon atom, here 3 valencies are satisfied. Remaining one valence is satisfied by one hydrogen atom. Here only one valence is satisfied. Remaining three valence is satisfied by three hydrogen atom. This carbon satisfied only one valency. Remaining three valence is satisfied by three hydrogen atom. And molecular formula of this structure is also C4. Count the hydrogen atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. This is C4H10 and this is also C4H10. Both molecules have molecular formula C4H10. But first molecule is a chain molecule. Carbon atom connected like a chain. And the second molecule is a branched molecule. Second molecule is a branched molecule. It's not a chain. One branch is there. One branch means carbon connected to carbon. A carbon atom connected in the chain. That is branch. Second one is branched molecule and first one is chain molecule. Okay, is it clear? The chain, first one is chain molecule, second one is branched molecule. But both have same molecular formula C4H10. But both are two different molecules. Same molecular formula but different structural arrangement. First one is chain, second one is branched. But both have same molecular formula. Both molecular formula but different structural arrangement. That type of molecule is known as isomers. Isomers. Same molecular formula but different arrangement or different structures are called isomers. They are structural isomers. They are structural isomers. Structural isomers. Okay. In some cases, some compounds have carbon atom arranged in the form of rings. For example, cyclohexane. For example, cyclohexane. Cyclohexane. C6H12. C6H12 is cyclohexane. That means cyclo means carbon atom is arranged in a cyclic manner. Cyclic manner. 6 carbon atom arranged in cyclic manner. Here, each carbon atom satisfied their valency, 2 valencies, and remaining 2 valencies satisfied by hydrogen atom. Remaining 2 valencies satisfied by hydrogen atoms. Okay. This is the structure of cyclohexane. Cyclohexane. Carbon atoms arranged in the cyclic manner. Closed structure. That type of molecules are known as cyclic compound. For example, cyclohexane. Formula of cyclohexane is, molecular formula is C6H12. Hope it's clear. Today we are going to discuss structural isomerism. Structural isomerism. What is isomerism? We know that iso means same. Isomers means a compound having same molecular formula but different chemical and physical properties. Compounds having same molecular formula but different chemical and physical properties are known as isomers. Today we are going to discuss structural isomers. Structural isomers. That means a compounds with the same molecular formula but different structural arrangement. A compounds with the same molecular formula but different structural arrangement are called structural isomerism. What is isomerism or what is isomers? Compounds having same molecular formula but different chemical and physical properties are called isomers. Compounds having same molecular formula but different chemical and physical properties are called isomers. The properties is called isomerism. And one type of isomer is structural isomers. What is structural isomers? Compounds with the same molecular formula but different structural arrangement. For example, butane and isobutane. We know that molecular formula of butane is C4H10. C4 means it contains 4 carbon atom and H10. In the first carbon atom, here only one valency is satisfied. So, another three valency satisfied by hydrogen atom. In the second carbon atom, here two valencies are second and third carbon atom. Two valencies are satisfied. The remaining two valencies satisfied by hydrogen atoms. And the last carbon atom, only one valency is satisfied and remaining three valencies of carbon satisfied by hydrogen atom. CH3, CH2, CH2, CH3. This is butane. Molecular formula C4H10. Structural isomer of butane is isobutane. This is butane. This one is butane. And isobutane. Isobutane is like this. 3 carbon atom connected like this, and the fourth carbon atom connected to the second carbon atom. The fourth carbon atom acts as a branch. And the first carbon atom satisfied only one valency, and the remaining three valencies satisfied by hydrogen atom. The second carbon atom satisfied three valencies and remaining one valency satisfied by hydrogen atom, and these two carbon satisfied only one valency and remaining three valencies satisfied by hydrogen atom. See the molecular formula of this compound: 1, 2, 3, 4. Total number of carbon atom 4, and count the hydrogen atom 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen atom. So the molecular formula of this compound is also C4H10. First compound is also C4H10. But first compound is butane. 4 carbon atom connected in chain. And second compound is known as isobutane. This one is isobutane. This one is isobutane. Butane and isobutane are structural isomers. Structural isomers. They have same molecular formula but different structural arrangement. Or different structures. Okay. Then next topic is hydrocarbon. Hydrocarbon. Hydrocarbon, that means a compound containing only hydrogen and a carbon. Hydrocarbons, the compounds of carbon and hydrogen only. That type of carbon hydrogen compounds are known as hydrocarbon. Hydro means hydrogen and carbon. Hydrogen carbon compounds that are called hydrocarbon. And hydrocarbon classified into 3 types. Hydrocarbons classified into 3 types. Hydrocarbons means compound containing carbon and hydrogen only. That types of compounds are known as hydrocarbon. It's classified into 3 types: alkane, alkenes and alkynes. Alkenes and alkynes. We know that alkanes are single bonded compound. Alkanes are single bonded compound. Single bond means between two carbon, number of bonds between two carbon atom is single bond. Alkenes are double bonded compounds. That means between two carbon atom, number of bonds between two carbon atom is double bond. Any one of the carbon bond is double bond. That type of molecule is known as alkene. And alkynes, a trip in alkynes, triple bonds are present. Alkynes, triple bonded compound. Triple bonded compound are known as alkynes. Single bonded compound, all bonds or carbon-carbon bonds are single bond. That type of molecules is known as alkanes. Any one of the carbon-carbon bond is double bond, the molecule is alkene. And any one of the carbon-carbon bond is triple bond, the molecule is alkyne. And we also know that alkanes. Alkanes are saturated compound. Saturated. Alkanes are, all alkanes are saturated compound. Alkenes and alkynes, they have multiple bonds, so they are unsaturated compound. Alkanes and alkenes are unsaturated. Unsaturated compounds. Unsaturated compounds. And alkanes. The name end with alkanes is ANE. And the name ends with alkenes is ENE. And the name ends with alkynes is YNE. Okay. Then if the number of carbon atom is 1, number of carbon atom is 1. The word root of the compound is meth. If number of carbon atom is 1, the word root of the compound is meth. If it is single bonded compound, the name ends with the ANE, so the name of the molecule is methane. Methane, that means methane. The word root is meth, that means the compound containing only one carbon atom, and the name ends with ANE, that means it's a single bonded compound, methane. And the total number of carbon atom present in the compound is 2. Total number of carbon atom present in the compound is 2. The word root is eth. Word root is eth. Number of carbon atom present, number of carbon atom is 2. The word root of the compound is eth. If all carbon-carbon bond is single bond, the name ends with the ANE. That means it's alkane. That means the name of the compound is ethane. Ethane. That means ethane containing total number of carbon atom. Word root is eth. That means total number of carbon atom 2, and all carbon bond is single bond, ethane. If total number of carbon atom is 2 and one double bond is present, that means the compound is alkene. Double bond is present means the compound is alkene, and the name of the compound is ethene. Eth stands for it's containing 2 carbon atom, and ENE for double bond is present. If the number of carbon atom is 2 and a triple bond is present, so the name of the compound is ethyne. What is ethyne? Eth for 2 carbon atom, and YNE stands for it containing a triple bond, ethyne. Ethane, total number of carbon atom 2, and carbon-carbon bond, all carbon-carbon bonds are single bond. Ethene, number of carbon atom 2, and carbon-carbon bond is double bond, ethyne. Number of carbon atom is 2 and one triple bond is present. Okay. And number of carbon atom is 3. Number of carbon atom is 3. The word root is prop. Word root is prop. Prop stand for number of carbon atom present in the compound is 3. And if all total number of carbon atom is 3, all carbon-carbon bonds are single bond, the molecule is alkane, and the name of the molecule is propane. Prop and ANE. Prop plus ANE. Propane. And total number of carbon atom 3, one double bond is present. one double bond is present. Total 3 carbon atoms are present. Any one of the carbon-carbon bond is double bond. That means the compound is alkene. So the name of the compound is propene. And any one of the bond is triple bond. Name of the compound is propyne. Is it clear? Number of carbon atom 3 means the word root is prop. If all bonds are single bond, that means the name of the molecule is propane. Any of the bond is double bond. The name of the compound is propane. And any of the bond is triple bond. Name of the compound is propyne. Okay. Then number of carbon atom is 4. Word root is but. Number of carbon atom is 5. Word root is pent. Number of carbon atom is 6. The word root is hex. And number of carbon atom is 7. Word root is hept. Number of carbon atom is 8. Word root is oct. Number of carbon atom is 9. Word root is non. Number of carbon atom is 10. Word root is dec. By heart this. 1 stands for meth. 2 for eth. 3 prop. 4 but. 5 pen. 6 hex. 7 hept. 8 oct. 9 non. 10 dec. Meth, eth, prop, but, pen, hex, hept, oct, non, dec. Okay. By heart this word root. Hept. Hept means number of carbon atom 7. Hept means number of carbon atoms 7. If all carbon-carbon bonds are single bond, the name of the compound. All carbon-carbon bonds are single bond means the compound is alkane. So the name ends with Ane. Total number of carbon atoms 7 and name ends with Ane. So the name of the compound is heptane. Okay, name of the compound is heptane. And any one of the carbon-carbon bond is double bond. And name of the compound, name of the name of this compound. Any one of the bond is double bond, that means the molecule is alkene and the name of the compound is heptene. And any one of the bond is triple bond, name of the compound is heptine. Okay, is it clear? Fill this table. Number of carbon atom, total number of carbon atom 4, word root but, and the corresponding alkane is butane. Alkene is butene and alkyne is butane. And the number of carbon atom is 5. All bonds are single bond and the name of the compound is pentane. Any one of the bond is double bond. The name of the compound is pentene. And any one of the bond is triple bond. The name of the compound is pentyne. Okay. And the total number of carbon atom is 6. The word root is hex and the all carbon-carbon bonds are single bond and the compound name is hexane. Any one of the bond is double bond. That means it's an alkene. Name of the compound is hexene. Any one of the bond is triple bond. The name of the compound is hexyne. Then hept, heptane, heptene, heptine and oct. All bonds are single bond or saturated compound is octane. And alkene, corresponding alkene is octene. Corresponding alkyne is octine. And non. Number of carbon atom is 9. It stands for non. And corresponding alkane is nonane. Alkene is nonene. And alkyne is nonine. Okay. And last one, dec. Dec stands for total number of carbon atom is 10. 10 and the corresponding alkane is decane. Alkene is decene and alkyne is decyne. Okay. By heart the word root and number of carbon atom. 1 meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. Meth, eth, prop, but, pent, hex, hept, oct, non and dec. Okay. Then next one, carbon compounds with a functional group. Carbon compounds with a functional group. Functional group. What is functional group? Functional group means atoms or group of atoms. Atoms or group of atoms that gives characteristics properties to a compound. That is called functional group. Atoms or group of atoms that gives a characteristics property to a compound. That is called a functional group. Suppose a chlorine atom is attached to methyl group. The compound is CH3Cl, chloromethane, CH3, carbon connected to 3 carbon atom and 1 chlorine. Carbon, only 1 carbon atom is there, that means meth. And chlorine is connected to this hydrocarbon. Chlorine is here chlorine acts as a functional group. Chlorine is a functional group. This compound is chloromethane. And some common functional groups are chlorine or bromine, halo compound. Chlorine or bromine attached to alkane, known as haloalkanes. Suppose chlorine attached to methane, the molecule is chloromethane. Chlorine attached to propane, the molecule is chloropropane. Chlorine attached to nonane, the molecule name is chlorononane. Or bromine attached to hexane, that molecule name is bromohexane. Hexane means the number of carbon atom is 6. That means bromine attached to 6 carbon compound containing 6 carbon atom. The molecule is bromohexane. Formula of the functional group. Chlorine Cl and bromine Br. Substitutes for hydrogen atom. We know that methane. Molecular formula of methane is CH4. CH4 is methane. But chloromethane or bromomethane means this hydrogen atom is replaced and here bromine or chlorine bonded to that carbon atom. Bromine or chlorine substitute for hydrogen atom. Okay, this is bromomethane. Bromomethane. And next, oxygen containing functional groups. Oxygen containing functional group. First one, alcohol. Alcohol. Alcohol is OH. OH group is attached to carbon atom. OH group is attached to carbon atom. And aldehyde. Aldehyde is CHO. Aldehyde, CHO. The bond like this. Carbon connected to hydrogen and carbon connected to double bond O. That is CHO. Aldehyde, CHO. And ketone. Ketone is CO. CO. CO, carbon oxygen. And carboxylic acid. The carboxylic acid, formula of carboxylic acid is COOH. COOH is carboxylic acid. See, carbon atom attached to alkane or alkane group, and carbon oxygen double bond is present and carbon connected to OH group. That is carboxylic acid, COOH. Haloalkanes is chlorine or bromine, chloro or bromo compounds. Alcohol, functional group is OH. Aldehyde, functional group is CHO. Ketone, functional group is CO. And carboxylic acid, functional group COOH. COOH is carboxylic acid. Is it clear? These are some important functional groups. Haloalkanes, alcohol, aldehyde, ketone and carboxylic acid. Okay. Next one, Homologous series. Homologous series. Homologous series means the series of compound in which the same functional group substitute for hydrogen in a carbon chain. Okay, the series of compounds in which the same functional group substitute for hydrogen in a carbon chain. Members of homologous series, they have the same functional group and differ by CH2 unit, differed by CH2 unit. Suppose alkanes. First alkane is methane. Molecular formula is CH4 alkane. Molecular formula CH4. And second member of the alkane series is ethane. We know that E stands for 2 carbon atom. So the structure of ethane is C2 and each carbon atom satisfied only one valency and remaining 3 valencies satisfied by hydrogen atom. C connected to first carbon atom connected to 3 hydrogen atom and second carbon atom is also connected to 3 hydrogen atom. And the molecular formula, total number of carbon atom 2 and total number of hydrogen atom present in ethane molecule is 6. C6H6. And next member is propane. We know that propane, it containing 3 carbon atoms. Here first carbon atom satisfied only one valency. So remaining 3 valencies satisfied by 3 hydrogen atom. Second carbon atom satisfied 2 valencies and remaining 2 valencies satisfied by hydrogen atom. Then the third carbon atom satisfied only one valency, remaining 3 valencies satisfied by 3 hydrogen atom. And the molecular formula propane C3, total 3 carbon atoms present. And number of hydrogen atom, total number of hydrogen atom 3 plus 2 plus 3, that is 8, C3H8. In homologous series, they differ by a CH2 unit. Here methane and ethane molecule. See the difference. Methane is CH4 and ethane is C2H4. They differ by 1 carbon and 2 hydrogen. Differ by a CH2 group. Methane, molecular formula of methane is CH4 and molecular formula of ethane is C2H6. Differ by CH2 unit. See ethane and propane, molecular formula of ethane is C2H6. And the molecular formula of propane is C3H8. See the difference. Number of carbon atom differed by 1, C2 and C3. That means one carbon atom, number of carbon atom differed by 1 and hydrogen atom is 2, CH2 difference. That means the adjacent members in a homologous series, the members of homologous series, they differed by CH2 unit. Propane is C3H8. Next member, prop. Next member is butane. The molecular formula of butane, C3H8 plus CH2. That means C4H10. Molecular formula of butane is C4H10. Molecular formula of pentane. Pentane is C5H12 because all members differed by CH2 unit. The adjacent members differed by CH2 unit. Alkane. Example for homologous series is alkanes. Alkynes. These are example for homologous series. Then it show gradation in physical property. They have similar chemical properties. For example, almost all alkanes show similar chemical properties. Example, alkanes. CH4 methane, C2H6 ethane, C3H8 propane, and C4H10 butane, etc. And alcohols, alcohol series, CH3OH, C2H5OH, C3H7OH. See the difference. Alcohol CH3OH. First alcohol is CH3OH. It containing only one carbon atom, CH3OH. It is methanol. And second one, it containing two carbon atoms, C2H5OH. Two carbon atom means word root is eth. And the functional group is alcohol. So the name is ethanol. Eth and name end with the ol, ethanol. See the difference? Carbon difference only one. CH3H5. How many hydrogen atom differed by? Two hydrogen atom. Oxygen 0, hydrogen difference 0. And the total difference is CH2. They differed by a CH2 unit. Okay. Methanol and ethanol. And C2H5, C2H5OH and C3H7OH. Carbon difference only one. Hydrogen C5H7 difference 2. And one oxygen difference 0. One hydrogen difference 0. Total difference is CH2 unit. Okay. The next topic, nomenclature of carbon compounds. Nomenclature means naming of the carbon containing organic compound. Following IUPAC naming system. IUPAC means International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. IUPAC. International Union of Pure and Applied Chemistry. IUPAC naming system. First step, steps for naming common. First step is identify the longest carbon chain. First identify the longest carbon chain. The longest carbon chain is known as parent chain. Okay. First identify the longest carbon chain. And the longest carbon chain is known as parent chain. Suppose 6 carbons arranged like this. 1, 2, 3, 4, 5, 6. 6 carbon arranged like this, and the same 6 carbons arranged like this. 2, 3, 4, 5, 6. In both the case, total number of carbon atom is 6. And first step is identify the longest carbon chain. Here, 6 carbon atom is arranged in a chain. This is the longest carbon chain, and in this case, this longest carbon chain containing 6 carbon atom. But in the second case, the longest carbon chain containing only 5 carbon atom. Longest carbon chain containing only 5 carbon atom. But in this arrangement, longest carbon chain containing 6 carbon atom. Here, longest carbon chain containing 6 carbon atom, but here only 5 carbon atom. This carbon atom acts as a branch. It not containing the longest carbon chain. Okay. So first step is identify the longest carbon chain. Identify the longest carbon chain. Longest carbon chain is the parent chain. Then second step, number the carbon atom. First step, identify the parent chain or longest carbon chain, and second step, number the carbon atom. Then next step, identify the functional group and use the appropriate suffix or prefix. Identify the functional group. Chlorine, bromine, alcohol, aldehyde, carboxylic acid, etc. Identify the functional group and use the appropriate suffix or prefix. And last point, for unsaturated compound, use suffix ene for double bonds and yne for triple bonds. We know that. Unsaturated compounds are alkenes. Unsaturated compounds are alkenes and alkynes. Alkenes are double bonded compounds and alkynes are triple bonded compounds. The unsaturated compound use suffix ene. That means the name of alkenes end with the ene. And name of alkynes end with the YNE. Use the suffix YNE. And in the case of single bonded compound, single bonded compound, use suffix, yes, ANE. Use suffix ANE. Use suffix ANE for single bonded compound, ENE for double bonded compound, and YNE for triple bonded compound. Okay. See this one. For example, haloalkanes. Haloalkanes. If the functional group is chlorine, use prefix chloro. And functional group is bromine, use the prefix bromo. Prefix. If alkane is the functional group, use it as prefix. Chloro for chlorine and bromo for bromine. And see this here. Count the first step. Count the total. Count the longest. Find the longest carbon chain. Longest carbon chain. This is the longest carbon chain. And count the number. 1, 2, 3. Total 3 carbon atoms are present. And 1 carbon atom connected to chlorine atom. Total number of carbon atom 3 means word root is prop and all carbon-carbon bonds are single bond. That means it is an alkane. So name end with the ANE. Propane. Propane. And the functional group is chlorine. Chlorine used as prefix chloro. So the name of this compound is chloropropane. Chloropropane. Okay. Is it clear? Find the longest carbon chain and number it. Here total number of carbon atom is 3. 3 stand for prop and all carbon-carbon bonds are single bond. So the name end with ANE. The name of this compound is propane. And the functional group is chlorine. Chlorine is used normally used it as prefix chloro. So the name of the compound is chloropropane. Next compound, total number of carbon atom 1, 2, 3. Total number of carbon atom 3 and 1 bromine is here. Bromine means bromo. The name of the compound is bromo. Prop, all carbon-carbon bonds are single bond. That means propane, bromopropane, chloropropane and bromopropane. Okay. Next one, alcohol. Alcohol used as suffix. Here we already discuss identify the functional group and use the appropriate suffix or prefix. Chlorine or bromine, halo compound it used as prefix. But alcohol, aldehyde, ketone, carboxylic acid, alkanes, they used as suffix. Alcohol, name ends with all, use the suffix all. Then first step, find the carbon atom, longest carbon chain and count the number of carbon atom. 1, 2, 3. Total 3 carbon atoms. That means word root is prop. And alcohol, name ends with the all. The name of this compound is propanol. We know that if instead of OH, here hydrogen is there, the compound is propane. But one hydrogen is replaced by OH group. So the name of the compound is propanol. The name with all, not ANE, all. And next functional group is aldehyde. Used as suffix al. Aldehyde used as suffix al. Then count the number at aldehyde. Aldehyde is a CHO group. It containing also a carbon atom. And count the number carbon atom here CHO. That is aldehyde. It containing a carbon atom. So count it. This one also first carbon atom, second, third. Total number of carbon atom is 3. 1 for aldehyde and 2 for alkane. two carbon atom, remaining two carbon atom is from alkanes. The total number of carbon atom is 3. And total number of carbon atom 3. The word root is prop and name ends with a al. Name of the compound is propanol. Not propane, it's propanol because aldehyde is there. The next functional group is ketone. Ketone is CO group. Used as the suffix one, ketone, one. And here, this is the keto group, CO group. Count the number of carbon atom. 1, 2, 3. Second carbon atom is a keto group. Total number of carbon atom 3. That means prop and name ends with a one, propanone. Name of the compound is propanone. Instead of propane, you can write propanone because CO group is there. CO group. The next functional group is carboxylic acid. Carboxylic acid, COOH. Use the suffix oic acid. Oic acid. Oic acid. Here COOH. This is the carboxylic acid group. Count the number of carbon atom. 1, 2, 3. Total number of carbon atom is 3. The molecule is propanoic acid. Propanoic acid. Noic acid for carboxylic acid group. Propanoic acid. Then next alkene. Use the suffix ENA. Here total number of carbon atom is 3 and first and second carbon atom containing a double bond. That means the molecule is unsaturated or alkene. So the name ends with ENE. Total number 3. First and second containing a double bond. The molecule is propane. Propane. And alkyne. Alkyne used as a suffix YNE. Alkyne. YNE. Here 1, 2, 3. Total 3 carbon atoms are present. First and second carbon atoms. Bond between first and second carbon atom is triple bond. That means the compound is alkyne. And the name of the compound is propyne. Name of the compound is propyne. Okay. This is some common functional group and examples. Then chemical properties of carbon compound. First chemical property is combustion. Combustion means burning in oxygen or air. Burning in oxygen or air with the production of heat and light. That is combustion. We know that. Combustion means burning. Burning in the presence of oxygen or air to produce heat and light energy. Carbon compounds burns in oxygen to form carbon dioxide and water. Carbon dioxide and water. Carbon compounds burns in the presence of oxygen to produce carbon dioxide and water, and it also liberates heat and light energy. For example, CH4. CH4 is methane molecule. It burns in the presence of oxygen to form CO2, H2O and heat plus light. And C2H5OH. C2H5OH is total number of carbon atom 2 and the functional group is OH. That means this molecule is ethanol. And it burns in the presence of oxygen. It's also form carbon dioxide and water molecules and liberate heat and light energy. So all hydrocarbons or carbon containing compounds burns with oxygen to form carbon dioxide and water molecule. Complete oxidation or complete burning to form carbon dioxide and water molecules. Then saturated hydrocarbon. Saturated means single bonded. Saturated hydrocarbons generally give a clean flame. And unsaturated hydrocarbon means double bonded or triple bonded compound. Double bonded or triple bonded hydrocarbons. They give yellow or sooty flame due to incomplete combustion. It gives yellow or sooty flame due to incomplete combustion. But saturated hydrocarbons generally give a clean flame. Next one, oxidation. Oxidation. That means we know that what is oxidation? Oxidation means addition of oxygen, addition of oxygen or removal of hydrogen. The process is known as oxidation. Alcohols can oxidize to carboxylic acid. The functional group of alcohol is OH, and it oxidizes to form carboxylic acid. Carboxylic acid is COOH. Alcohol oxidized to form carboxylic acid. Okay. Suppose ethanol. Ethanol is C2H5OH. Okay. This one is oxidized ethanol, alcohol. Total number of carbon atom 2, and the molecule is functional group OH. It is ethanol. It is oxidized to form corresponding carboxylic acid. The total number of carbon atom is 3. So the corresponding carboxylic acid is ethanoic acid. CH3COOH, ethanoic acid. Okay. Alcohol can be oxidized to corresponding carboxylic acid. Example, ethanol, C2H5OH and 2O. This means oxidation. Oxidation to form CH3COOH, CH3. C2H5OH is ethanol, CH3. CH3 means this first carbon atom connected to 3 hydrogen atom, and COOH plus water molecule. And oxidizing agent. Oxidizing agents are alkaline cheminophore. Oxidizing agent helps oxidation. It's alkaline cheminophore, acidified K2Cr2O7. Okay. Alkaline cheminophore and acidified K2Cr2O7. Alkaline cheminophore is alkaline potassium permanganate, and acidified K2Cr2O7 is potassium dichromate. Alkaline potassium permanganate and acidified potassium dichromate are strong oxidizing agents. And next one, addition reaction. Addition reaction is a characteristic of unsaturated hydrocarbons. And addition reactions means addition reaction, addition of atoms to the carbon atoms at the double bond or triple bonded compound. Addition of atoms to the carbon atom at the double or triple bond. For example, hydrogenation of vegetable oil. Unsaturated fat plus hydrogen to form saturated fat in the presence of nickel catalyst. Used in the food industry to convert vegetable oil to vanaspati ghee. And for example, CH2 double bond CH2. Ethene molecule react with the hydrogen. Ethene molecule plus hydrogen atom to form CH3. Ethane molecule. Unsaturated compound converted to saturated compound. Double bond or triple bond. Double bonds or triple bond break and to form corresponding saturated compound. That is addition reaction. And substitution reaction. It is characteristics of saturated hydrocarbon. Addition reaction is a characteristics of unsaturated hydrocarbon. Substitution reaction is characteristics of saturated hydrocarbon. And substitution. That means replacement. Substitution, we know that substitution means replacement. Substitution reaction means replacement of one atom by another atom or group of atoms. Replacement of one atom by another atom or group of atom is called substitution reaction. Suppose CH4 is methane plus chlorine. Here replace one hydrogen atom by chlorine atom. Replace one hydrogen atom, CH4. plus Cl2. Replace one hydrogen atom by chlorine atom to form CH3Cl plus HCl in the presence of sunlight. This reaction carried out in the presence of sunlight, HNU or sunlight. And some important carbon compounds is we are discussing about some important carbon compounds, ethanol and ethanoic acid. First we are going to discuss ethanol. Molecular formula of ethanol is C2H5OH. C2H5OH. Molecular formula of the compound is C2H5OH. And the properties of ethanol. Properties of ethanol. It's liquid at room temperature. Ethanol is liquid at room temperature and colorless volatile liquid with characteristic odor. Colorless volatile liquid with characteristic odor. Ethanol is liquid at room temperature and it is colorless and it is a volatile liquid. Volatile liquid means it easily evaporate. With the characteristics odor. And it is soluble in water in all proportions. It is soluble in water in all proportions. And boiling point of ethanol is 351 Kelvin. Melting point is 156 Kelvin. That means very high boiling point and a melting point. We know that boiling point of water is 100 degrees Celsius. 100 degrees Celsius means 100 degrees Celsius converted to Kelvin scale. 100 plus 273 Kelvin. That means 373 Kelvin. Boiling point of water is 373 Kelvin. Boiling point of ethanol is 351 Kelvin. That means it's less than water. Boiling point of water. And melting point is equal to 156 Kelvin. Melting point is 156 Kelvin. Melting point of ice. Yes, ice melted 0 degrees Celsius. 0 degrees Celsius means 273 Kelvin. Melting point of ethanol is 156 Kelvin. And chemical reaction of ethanol. Reaction with the sodium. Ethanol C2H5OH. It's react with the sodium metal. Sodium metal to form sodium ethoxide. Sodium ethoxide. Formula of sodium ethoxide is C2H5ONa and hydrogen gas, H2 gas. Reaction with ethanol react with the sodium to form sodium ethoxide and hydrogen gas. Okay. Next, dehydration reaction. Ethanol react with the ethanol in the presence of hot concentrated sulfuric acid to form C2H4. C2H4 is ethene. Molecular formula of ethene is C2H4 and water. It's a dehydration reaction. Dehydration means removal of water molecule. Here water molecule is removed. That means it's a dehydration reaction. Decarboxylation reaction means removal of carbon dioxide. Here water molecule is removed, so the reaction is known as dehydration reaction. Alcohol react with any concentrated acid, it liberates water molecules. Here ethanol react with the hot concentrated sulfuric acid. Ethanol react in the presence of hot concentrated sulfuric acid to form C2H4. C2H4 is ethene and also form water molecules. It eliminates water molecules, so the reaction is called dehydration. And oxidation process. Oxidation means addition of oxygen. We know that alcohol oxidized to form corresponding carboxylic acid. So ethanol oxidized to form corresponding acid, corresponding carboxylic acid. Ethanol oxidized to form corresponding carboxylic acid, that is ethanoic acid. CH3COOH is ethanoic acid plus water molecule. CH3COOH ethanoic acid. And use of ethanol. It is used as a solvent in medicines. Then in alcoholic beverages, then it is used as a fuel, and it is used in thermometers. Okay. Next compound is ethanoic acid. Molecular formula is CH3COOH. CH3COOH, that is ethanoic acid. And property of ethanoic acid. It is liquid at room temperature, freezes as 290 Kelvin, and glacial acetic acid. And its shortest dilute solution is called vinegar. 5 to 8% dilute solution of ethanoic acid is called vinegar, vinagiri. And it is a weak acid. Ethanoic acid or acetic acid or vinagiri is a weak acid. Vinegar is a weak acid. That means it partially ionized in water. Strong acid means it is completely ionized in water. HCl, H2SO4, they are strong acids. They completely ionized in water. But ethanoic acid is a weak acid. That means it partially ionized in water. The dilute solution, 5 to 8% dilute solution of ethanoic acid is known as vinegar. The common name of ethanoic acid is acetic acid. It is also known as acetic acid. Ethanoic acid and acetic acid both are same. So 5 to 8% dilute solution of ethanoic acid or acetic acid is known as vinegar, vinagiri. We know that the taste of vinegar is sour taste, and it is a weak acid that is partially ionized in water. And chemical reaction of ethanoic acid. This one is important reaction, esterification. Esterification. Esterification means formation of ester. Formation of ester. Esterification means formation of ester. How to form ester? And carboxylic acid. Any carboxylic acid and carboxylic acid and alcohol. Any alcohol. To form ester. Carboxylic acid react with the alcohol to form ester. Carboxylic acid react with the alcohol to form ester. Carboxylic acid, CH3COOH, acetic acid or ethanoic acid. It is an example for carboxylic acid. It react with the C2H5OH. C2H5OH is ethanol, alcohol, to form CH3COO C2H5. This is an ester. CH3COO C2H5. Functional group of ester molecule is COO. COO. The compound is the name of this compound is ethyl. C2H5 for ethyl. CH3 for CH3CO for ethyl. Ethyl ethanoate. Ester. Ester, the name of ester end with the OATE. OATE. The name of the compound is ethyl ethanoate. Esterification means carboxylic acid. Any of the carboxylic acid react with the alcohol to form corresponding ester. For example, acetic acid or ethanoic acid react with the ethanol to form ethyl ethanoate plus water. The reaction with the ethanol to form an ester. Ester. Alcohol plus acid. Alcohol plus carboxylic acid to form ester. Ester have pleasant fruity smell. It is used in perfumes. Then reaction with the base. Ethanoic acid plus base, NaOH. NaOH is a base, sodium hydroxide, to form sodium ethanoate or sodium acetate. Sodium acetate, CH3COO Na plus H2O. Reaction with the carbonate and hydrogen carbonate. Ethanoic acid react with the sodium carbonate to form sodium acetate, water and carbon dioxide. And ethanoic acid react with the sodium bicarbonate or sodium hydrogen carbonate, NaHCO3. It also forms sodium carbonate, sodium acetate, water and carbon dioxide gas. Okay. Then uses of ethanoic acid used as vinegar in 5 to 8 percentage of acetic acid. 5 to 8 percentage of acetic acid or ethanoic acid is vinegar. It is used in food preservatives. Then in the preparation of ester, how to form ester? Esterification reaction is carboxylic acid plus alcohol to form ester. Carboxylic acid plus alcohol to form ester. The process is called esterification. Okay, carboxylic acid plus ester to form carboxylic acid plus alcohol to form ester. In the manufacture of artificial fibers and the preparation of acetate rayon. Then next topic, soaps and detergent. Soap is a sodium or potassium salt of long chain carboxylic acid. Sodium or potassium salt of long chain carboxylic acid. It prepared by saponification. Preparation of soap. It is prepared by saponification. Saponification means hydrolysis of fat with sodium hydroxide. The process is called saponification. Soap is prepared by saponification method. Structure of soap. Soap containing a long hydrocarbon chain. That chain is called a long hydrocarbon chain. The part is hydrophobic. The long hydrocarbon chain part is hydrophobic. Hydrophobic means water repelling end. Hydrophobic, that means water repelling. And one ionic end. Ionic end is hydrophilic. Hydrophilic is water attracting end. Like this. This is the head portion of the soap and this is the tail portion of the soap. This tail portion, that is the longest hydrocarbon chain. This one is the longest hydrocarbon chain, and the tail part is water attracting end, that is an ionic end. And long chain hydrocarbon chain is head part is hydrophobic end, that is water repelling end. Head part is hydrophobic and tail part is hydrophilic. Hydrophobic is water repelling end and hydrophobic is water repelling end, and hydrophilic they love water attracting end. Ionic end is the hydrophilic and long hydrocarbon chain is hydrophobic. And cleansing action of soap. When soap is dissolved in water, it forms micelles. Micelle formation. Soap dissolved in water to form micelles. In micelles, the hydrophobic tail are directed inwards and hydrophilic heads outward. We know that hydrophobic means water repelling part. Water repelling part is longest hydrocarbon chain part is water repelling part. That is the tail part. It's directed inwards and a hydrophilic head. Hydrophilic means water loving part. Water loving heads outward. In micelle formation, the hydrophobic tail are directed inward and hydrophilic heads outward. And dirt and grease get trapped inside the micelles. The micelles remain suspended in water as a colloid and were washed away. Like this. See the soap molecule. This is the head portion and this is the tail portion, and the tail portion attached to the oil droplet or grease particle, and head portion outward to the oil droplet, and head portion is water. Tail portion is water hydrophobic part, that means water repellent part. Tail part is water repellent and head part is hydrophilic, water attractive part. Water attractive part or ionic part or hydrophilic part is containing Na plus ions, and tail part is hydrophobic part, water repellent part. Okay, this is the micelle formation. Center oil drops, it's covered by soap molecules. Then limitation of soaps. It does not work well in hard water. It forms insoluble calcium and magnesium salt with Ca2 plus ion and Mg2 plus ions in hard water. The next one, detergent. In hard water, we can use the detergent. This detergent is sodium salt of sulfonic acid or ammonium salt. Sodium salt of sulfonic acids or ammonium salt. But soap means sodium or potassium salt. Detergent is sodium salt of sulfonic acid or ammonium salt. And structure similar to soap but with a different ionic group. Advantages over soap. They work well in hard water and do not form insoluble calcium or magnesium salt. And it is used in shampoos and for cleaning clothes. Okay. These are the some important topics. I hope it's clear. Next compound is ethanoic acid. Ethanoic acid. Molecular formula of ethanoic acid is CH3COOH. Ethanoic acid is also known as acetic acid. Ethanoic acid also known as acetic acid. The common name of ethanoic acid is acetic acid. Then properties of ethanoic acid. It's liquid at room temperature, freeze at 290 Kelvin, and it's sought to test dilute solution, 5 to 8% dilute solution. 5 to 8% dilute solution is called vinegar, and it is a weak acid. Weak acid means it partially ionized in water. Acetic acid or ethanoic acid is a weak acid. That means it is partially ionized in water to form corresponding ions. And 5 to 8% of 5 to 8% dilute solution of ethanoic acid is known as vinegar. Next, chemical properties of ethanoic acid. First chemical property is esterification. Notice this is an important reaction, esterification reaction. Esterification. CH3COOH, acetic acid or ethanoic acid. It reacts with the C2H5OH. C2H5OH is ethanol to form ester. Ester containing a COO group, COO, that is ester. CH3COO C2H5 is formed. This is ethyl ethanoate. Ethyl ethanoate. CH3COO C2H5 plus H2O. Esterification means formation of ester. Esterification means formation of ester. How to form ester? And carboxylic acid. Sorry, a carboxylic acid. Any of the carboxylic acid react with alcohol. Any of the alcohol. Carboxylic acid react with alcohol to form corresponding ester. Carboxylic acid react with alcohol to form corresponding ester. For example, ethanoic acid. Ethanoic acid is a carboxylic acid. It reacts with the ethanol. Ethanol is an alcohol to form corresponding ester. Corresponding ester is ethyl ethanoate. CH3COO C2H5. Here this OH group and this H plus ions combine to eliminate water molecules, and the remaining part is CH3CO COC2H5, that is ethanoic, ethyl ethanoate. Carboxylic acid react with the alcohol to form ester. That reaction is called esterification. Esterification means formation of ester. Esterification means formation of ester. The reaction of ethanol to form an ester. Here, ethyl ethanoate is formed. Either esters have pleasant fruity smell. It is used in perfumes. Then next reaction with a base. Reaction with base. Ethanoic acid or acetic acid react with the base. React with the base to form sodium acetate. Sodium acetate. Ethanoic acid react with a base like NaOH to form sodium acetate. Suppose ethanoic acid react with the KOH solution, it form potassium acetate. CH3COOH and NaOH it react and eliminate water molecule and form CH3COONA, sodium acetate. Sodium acetate. CH3COONA is sodium acetate. The next one, reaction with the carbonate and a hydrogen carbonate. Hydrogen carbonate is also known as bicarbonate. Bicarbonate. Reaction with the carbonates and a bicarbonate. CH3COH, ethanoic acid, react with the Na2CO3. Na2CO3 is sodium carbonate. Na2CO3 to form sodium acetate. Sodium acetate, and it liberates water molecules and carbon dioxide gas. And also ethanoic acid react with NaHCO3. NaHCO3 is sodium bicarbonate. Sodium bicarbonate. It is also known as sodium hydrogen carbonate to form sodium acetate or sodium salt of ethanoic acid, water and carbon dioxide gas. Next, uses of ethanoic acid. It is used in vinegar for food preservative. In the preparation of ester, we know that how to prepare ester. Ester, any carboxylic acid react with the alcohol. Carboxylic acid react with the alcohol to form corresponding ester. Ethanoic acid and ethanol react to form ethyl ethanoate. Then next use is in the manufacture of artificial fiber. Then in the preparation of acetate rayon. These are some uses of ethanoic acid. Next topic is soap and detergent. Soap. What is soap? Soap is sodium or potassium. Sodium or potassium salt of long chain carboxylic acid. Soap is a sodium or potassium salt of long chain carboxylic acid. Sodium salt of long chain carboxylic acid or potassium salt of long chain carboxylic acid is soap. It is prepared by saponification. Prepared by saponification process. Saponification means hydrolysis of fat with NaOH. Fat hydrolyzed in the presence of NaOH. That process is called saponification. So prepared by saponification process. Then next, structure of soap. Structure of soap. Soap containing a long hydrocarbon chain. Long hydrocarbon chain and an ionic end. And an ionic end. Long hydrocarbon chain and ionic end. The long hydrocarbon chain is called tail part and the ionic end is called head part. Tail part and head part. The long hydrocarbon chain, this is the long hydrocarbon chain, this is the tail part, and it is hydrophobic in nature. Hydrophobic. What is hydrophobic? Hydrophobic. Hydro means water, phobic means it hate. Hydrophobic means water repelling end. Hydrophobic part, tail part is the hydrophobic part. That means it is water repelling end. And ionic part or head part, it is hydrophilic part. Hydrophilic means water loving part. Hydro means water, philic means loving. Water loving part. The head part of the soap molecule is hydrophilic, that is water attracting end. And the tail part or long hydrocarbon chain part is hydrophobic nature. Hydrophobic. Long hydrocarbon chain part is hydrophobic and ionic end part is hydrophilic. Hydrophobic means water repelling end and hydrophilic means water attracting end. Then cleansing action of soap. When soap is dissolved in water, it forms micelles. Soap dissolved in water, it forms micelles. In micelle is the hydrophobic tails. Hydrophobic tails are directed inward and the hydrophilic head. Hydrophilic head. Hydrophilic head means water loving part. It pointing outward. Hydrophobic tail part are directed inward and hydrophilic head part pointing outward. The dirt and grease get trapped inside the micelles. The micelles remaining suspended in water are colloid and are washed away. This is the structure of micelle formation. This is the soap. This is the oil droplet, and this is the head part or water loving part, hydrophilic part, and this one is the tail part or water hating part, hydrophobic part of the soap molecules. Then limitation of soap. It does not work well in hard water. Soap work well in only soft water. It forms insoluble calcium and magnesium salt. It forms insoluble calcium and magnesium salt with Ca2 plus and Mg2 plus ions in hard water. Soap forms insoluble calcium and magnesium salt in hard water. Okay. Soap forms insoluble calcium and magnesium salt in hard water. The next topic is detergent. What is detergent? Soap is sodium or potassium salt of long chain carboxylic acid. Detergent is sodium salt of sulfonic acid or ammonium salt. Detergent is sodium salt of sulfonic acid or ammonium salt. That is called detergent. The structure is similar to soaps but with different ionic group. Advantages over soap. It works well in hard water. Detergent work well in hard water and it do not form insoluble calcium and magnesium salt. But in the case of soap, it form insoluble substance in calcium or insoluble substance like calcium salt or magnesium salt. But detergent do not form insoluble calcium or magnesium salt. It is used in shampoos and for cleaning clothes. These are some important topics. I hope it's clear.